Because Zodium in the Discord said, waiting for Joe to be extremely animated. Hi, everybody. It's Joe from Joe's Computer Museum. How are you all doing this evening? Thank you for thank all of you for stopping by. Brain, words can't do stuff. Yeah, so we'll get all of the silly stuff out of the way. First off, let's talk about what we're doing tonight. Tonight, we're going to be building a NeoPixel kit. If you don't know what that is, go way back in the past, way back in the far past of my channel, like 2 years ago. Basically, you can kind of see it behind me. It's right over here. I created a controllable RGB light strip for the clear case Apple IIe. That from software inside the Apple IIe, you can actually program the light strip to do different color patterns. I did that because, like, if you got this color Apple IIe case, you gotta trick it out. So I designed that. Well, one of my fans, followers, watchers, viewers, I'm not sure how you would classify the gentleman, but he saw my video on that, and he had a clear case Apple IIe, and he's like, I need you to make me one of those. Can you do that? I'm like, okay, I can do that. Give me money, dollars, and I will find time to make thing occur for you. So that is what we are doing tonight. I may get it done tonight. I may not. I don't know. I figured if I'm just going to sit here at the bench and tinker, I might as well share that tinker time with all of you and show you kind of how that process works. So, housekeeping stuff out of the way. Again, thank you all for stopping by. Remember to hit the like button if you liked my video, if you like the live stream here. That tells YouTube to show my content to other people who watch similar content that you watch. So if you're watching a lot of different videos and there are other people that watch the similar videos to you, but they don't know about me, if you hit the like button, it'll show that video to them. Audio video sync is way off. Oh no, let me fix that. Stand by. Stupid thing. Happens all the time. Doobie-doo. If I do this and do that. Is that better? Is that better? Better audio sync? Better audio sync? Sync audio better? Let me know. Better? Worse? 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 How is it worse? How did that happen? I thought Joe and JCM 1 was world famous. Thank you. Okay, stand by. I don't know why it's off by that much. Let's do... How's that? Is that better? Any better? Worse? That's it. Fixed it. Sweet. All right. Well, everything is messed up. Oh, okay. Apparently it's back. All right. We're gonna roll with that. I don't know. I usually don't have these problems with my stuff. So I'm also apparently have a very, very bad internet connection right now. This is really odd. Wow. Very, very weird. Way off again. All right. Let me see if I can fix this by doing this. So this may be a very screwed up. This may be a very screwed up short stream because I'm going to reload my browser. I will be back momentarily. Stand by. Oh my gosh, is that better? Any better at all? Better? Worse? Crappy? Good? We'll stick with it. All right. I don't know. All right, we're going to hang with that. Okay, welcome back, everybody. Now that we're 10 minutes into the stream and got absolutely nothing done, let's do the thing. So here we are. If you would like to contribute to the museum, let's get the housekeeping out of the way. If you'd like to contribute to the museum and send me like help and donations and stuff, so I can, I don't know, get fiber internet in my house so this stuff doesn't happen again. I don't know. It's delayed again. It's delayed again? Really? How? I never have problems with my streams, like ever. This is the first time I've ever had a problem. It's dubbed Japanese movie Joe. All right, we're going to do some other extreme things. I may disappear for a moment. Stand by. How's that? Is that better? Can you hear me? Can you see me? Hello? Hello? Still delayed. It's delayed on my end. Weird. Fixed for how long? Yep. Jiminy Christmas. Wow. I have never had these many problems. I'm going to be blaming StreamYard or my internet connection. Even worse. So how about okay. I don't get it. We can go into super simple mode. Let's do this. How that? Better? If I just decrease the video bitrate, I can't do that in StreamYard. Still off. I don't know why. I literally do not know why. Wow. So this is apparently has become the Joe wants to do a thing live and then breaks his internet. I am pressing buttons. Stand by. I'm getting 300 megabits down. Upgrade your 24K modem. No, that's not the problem. My upload speed is 10 megabits. I don't know what the deal is. I can try something different. We can try a different browser. Ten megabits is more than enough up speed for what I'm doing here. Yeah, I'm thinking it's a StreamYard problem because I'm having problems even getting into StreamYard. My internet here is also rock solid. Pretend you're on the International Space Station. Yeah. Do. It's a lot better now. Okay, well then we'll just hang with it. We will hang with it. Fine, we're moving on. We're moving on. I've been sitting here staring at the screen doing nothing for whatever. We're moving on. Deal with my audio being out of sync. So here we are. Donate to my channel if you want. It's in sync. Don't touch anything. Great. We're hanging with it. JCM-1.com is my my website where you can go and get trinkets, and you can go to my Patreon at patreon.com/Joe's Computer Museum. You can also follow me on a lot of social media, but because I don't have all my cool wibbly-doos on the screen right now to do the thing, I can't really show you the thing. So we're just gonna kind of roll with it, maybe? We will see what happens. So tonight what we are doing is we are building a NeoPixel kit. Basically, it's a pretty RGB light kit for the Apple II computer. Now, I've already designed this. I have all the code and stuff up on my website and all of that. Tonight, we're gonna build one, and I'm gonna kind of show you the process that goes into building one of these things. So let's see if I can show you some of the stuff that we're going to use to do this. So the first thing is you need an Arduino of some description. This is the Arduino R3, or the Arduino Uno R3, which is what I use for this because it's cheap, it's straightforward, it's easy to make work. You need a NeoPixel pixel kit. The ones that I get are this. It is a 1 meter kit, or 3.28 feet, however long you want to call it, that fits perfectly around the perimeter of the clear case back there. And also it has the right number of LEDs to not overpower many power supplies. It specifically will work well with a lot of different power supplies that you can get without killing them. You can get these LED kits that have like 120 LEDs or even more LEDs, lots more LEDs per inch basically, but they use way too much current and they can overdraw the power supply. The other thing you need for this kit is you need a good power supply. This is the Reactive Micro Ultimate Power Supply from reactivemicro.com. And I like this because you can power this kit and all of the current that it draws off the supply inside the Apple II itself without having to have an external like wall wart or something that you plug in inside the machine. So yeah, is this a 12-volt unit? I don't remember. I'll have to figure that out as we go. We will give it power and figure out what it does. So basically what this kit does is, I'll go back and explain the basics of how this works. So these things right here, they're little serially connected LEDs, and each of these LEDs has a tiny little microcontroller on it that has a specific kind of communication protocol baked into it. That comms protocol requires you to basically pulse the bits in and out at about 800 kilohertz. Super duper fast. It's basically nearly the maximum speed of the Apple II. The Apple II, in the tightest communication loop you could possibly imagine, cannot talk to these fast enough to program them directly. It can't do it. So you have to use something like an Arduino Uno in between. So basically what you do is I created a communications protocol that uses the gain port on the Apple IIe to bit bang certain commands to an Arduino that has programming in it that can interpret those commands, and it will then, using the NeoPixel library that's available for Arduinos, it will then send that data along at the proper speed to the lights so that they light up. That's basically how the thing go. That how do. So that said, let's get into doing that. I'm going to check something real quick to make sure my stream is still going correctly. It seems to be, yes. Cool. Christmas lights. Yes, basically. That's basically what it is Christmas lights. Now, this is pre-programmed with a certain set of color schemes in it that you can just toggle on and off. You can also pre-program it with different color patterns that you like. My only downside is I haven't added code to this yet to save that color pattern in between power cycles. I would like to add that code at some point. Maybe I'll do that as part of this project for this customer specifically, then backport it to my own thing. But that's the only major feature that's missing here. But you can, the AppleSoft program that's included with this kit allows you to explicitly state, I want the pixel at this position to be this color. I want the animation pattern to be this animation pattern, and it'll just do it. So it's pretty nifty. So let's see some things here and see if we can do some doobly-doos. I'm going to do this thing, and I'm going to do this thing. And that didn't work because it's dumb. Stand by. Cool. Because I need to get at least some sort of camera here going so you guys can see what I'm doing. Because you can't, like, yeah. I'm going to do this. How's my audio? Is it synced up now? Is it working? I hope so. So that doesn't work, but that's fine. We can deal with that. Cool. So let's get going. So we need to get this out of here. Simple, straightforward Arduino. Boop, 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 boop. Open. Do it. So there's the Arduino that we need to program. There's not much to that. Here's the wiring, or the LED kit. So we're just going to unspool this guy. Who cares, Joe? Build away. Yep, we're doing it. So, and I like this too because it's got this silicone film on it, which means that you can double-side it on either side fairly easily, and you're not going to short this out on anything inside the computer. If it comes loose, it's not going to be a problem. And so basically what we do here is this is where we feed our power and our signals in one end from the Arduino and then do the thing. So I just got to figure out exactly how I needed to do this. Yeah, basically, yeah. Doobie doobie doo. We're going to look at this to figure out what wires we need to use. Yeah. So it's 5 volts, ground, and data. So the ground is actually white for some reason. I don't know why, but it is. That's just how it is. But whatever. We're gonna roll with it. Rolling with it. Yeah, the Apple the Apple II is 1.023 megahertz average. It actually has a variable clock that isn't exact. One of the clock cycles per video frame is a half cycle longer or something like that. So we got the wire split out here. So those are split out so that I can tap into those. So that's going to be power, ground, and our data line. These we're just going to cut off because they're not important and don't go anywhere. Don't need those wires there at all. They're just out of the way and gone. So, ooh, somebody is like, what is that little log slice that says Timbuk? You're talking about that? Yeah, that's actually a very good question. This is the bottom slice off of my Christmas tree. We get it at Timbuk Farms in Granville, Ohio. And so, yeah, every year we keep the little slice and we note it, and I've got like a stack of 10 or 12 of them over there. And I just keep them around every year. So we need to get these wires stripped. I need to think about this for a second because what I need to do is also feed quite a bit of wire around the computer for this. So I need to kind of think about how much feed wire I need because I'm building this as a kit for the gentleman. And I'm going to just provide a a metric butt ton of cable, effectively. So that's basically what I'm doing. Now this LED kit is a 5-volt kit, which means it can be powered off the same voltage that this guy gets powered off of. So you know. So how much of that do we need? We probably need a good what? If that goes on that end and this goes on this end, the data needs to come in there. We'll need a data line that's at least the length of this for that. Actually, no, because the arrangement of this in the Apple II kind of is like this. It's kind of like that. And the game port's up here. This guy lives here, and we tap into these pins over here. So we're going to need one data pin only that comes off of this to go into this, because that's what signals that. And then there's several other data pins that come off of this that go to the Apple, over to the Apple II. So yeah, that's what we will do. You could make tree ornaments out of those slices. I could. That would be nifty. So let's do the thing. Let's, how much wire do we need? Like that much, maybe? I'm trying to look at my original over here and how much wire I gave it. It's about 8 inches. 8 inches. Something like that. Stand by. I am intelligencing the process here. I'm just trying to see how I built this. Ah, I see. And that just feeds all the way over to there. So I need about 16 inches of feed wire for the power here. So we'll do that first. If I can get enough wire to do it. Wire. And wire. So 16 inches or so. That's what she said. Ha 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 ha! You're naughty. Boop. About that much. It's about that much. You can't really see what I'm doing because I don't have the camera set up right. But so there's red wire. There's the red power wire for that. Because this actually kind of goes like that. So we want this to be able to come over here and go into the power supply like that. Yep. Works for me. And here is ground wire. Okay. That's what we need there. Cool beans. I'm going to leave this black wire out because we'll need some more of that. Never change, Joe. I'm trying to intelligence this. Never change, Joe. No intention to, Zodium. No intention to. Trust me. So we can create a little kind of braided pair for this so that they kind of stick together, so to speak. Like this. Okay. Have more coffee is my motto. Yes. Joe is brainstorming. That would require me to have a brain, Jeremy. Oh, cool. Here we go. There's that. So then we need to wire this up. I need some heat shrink, and I need to turn on my heat shrinky thing and all the different things. That gets turned on. I need heat shrink tubing. Okay. Keep this somewhere up on that. we go. So, do these. Always remember to put your heat shrink tubing on first. It's snowing there. Well, congratulations on your snow. Excuse me. Okay. So we need to heat shrink over those before we have to do anything with them. You can do it. There we go. Tin these leads. Pre-tin the leads. Pre-tinned. Pre-tinned. Pre-T-I-N-N-A-D, not P-R-E-T-E-N-D. Pre-tinned. Like that. And like this. Cool. Now we can connect these leads together very carefully. Like this. Now it's done. And then this one. Cool beans. Oh, hush. Then we heat shrink these doobles on here. There we go. Cool. So the main bus power connection for the NeoPixel strip itself is connected, so that's good. Might as well get these wires here stripped and tinned because we'll need to hook those up. Need to hook those up eventually. Solder goop, solder goop. Look at all the solder goop. There we go, pre-tinned for soldering. So that's good. So now I need to make a power lead for this, which is actually quite simple. Hold on, let me. So basically we just need to feed 5 volts right in here, and that should work just fine. And so I can make a little 5-volt power adapter that does that. So stand by. Let me get a barrel jack from way up here. And then we need more wire. We'll go with about 16 inches again. Again, because we're making this as a kit for installation by the customer. I don't know exactly how they're going to want to do the thing, so we're just doing it the way we see fit. Time for Joe to visit the Enterprise. Yes. Cool. Got another set of wires we can get put together. Imagine eating pintos and cheese with a side of cucumbers and washing it down with a Pilsner beer. No. Eric is here. I wish I could be watching this live, but I'm at a work event. Yes, Eric is the person I'm building this for. So hi, Eric. Just another little power lead here. This is starting to hurt my fingers. Cool. So that's that. This is our power feed. There we are. Boiled eggs for dessert. What are you making, Jeremy? What are you talking about, buddy? What is that? So solder. Pretend the weeds. This other side needs to go in this thing-a-doodle. Like that. Just have to remember which one's the center pin. That's this one. Center pin positive. Like that. Cool beans. Okay. So I need... What is he talking about? What are you talking about, Jeremy? What are you talking about? Center pin positive. It's that one there. Oops, almost forgot. This needs to go through here first. Yes, it does. Probably will work better this direction. Okay. Kind of just hold that so it doesn't move. That's not going to work. Like, go in the hole so I can solder you. Be one with the solder. You can do it. You can do it. You can. Flatulence. Why are we talking about flatulence? Because I made a noise. There we go. So you can see what I'm doing. How's that work? Get the wires twisted and connected. You can do it. You know that you can. Oh my gosh. Stop being dumb. I'm about ready to just solder it in there and just be like... We're just soldering it. We're just going to blech it. Is what we're doing. Just fill that in there. There we go. Works for me. We'll cut this little nub off here. Cool. So this can go up here like this. Cool. 5-volt connector. Cool. Now, what we can do is go back here. We can plug this in here and feed that 5 volts, and that will power this. You see? You see? I'll show you. Come here, you. Come here, connector doodles. We need to go to voltage and turn that up to 5 volts. Need my current level to be fairly high. And we go 5 volts and ground. There it is. It's running. Look at that. Cool beans. Cool. So, in theory, I can also do the same thing here. I can plug these into this power supply and get the same thing. So let's do that. That's going to be, I can actually disconnect this from this thing. Plug them into this so you can see that it works. I need this thing. So this can come out. And that's 5 volts. And this can come out because it's ground. Like that. Grounded 5 volts, just like that. So if I power this Apple IIe power supply up, it should work. Or it's going to explode, one or the other. It shouldn't explode at all. Here we go. That's it. So as you can see, you can barely see it, but this little orange light here is blinking, which means that the default code on here is on, the power's running. So that is a functional thing that we can do. Cool. Now, we've got 5 volts for that. This takes 5 volts. Now we need to have a bus, our bus line, effectively, that connects this to that, which is pretty straightforward, which is really just going to be, this is going to be set up. It's hard for you to see my layout here, but this kind of lives down here in the Apple II, and this end sits up here. So we just need a length of wire to go here to talk to this. So that's going to be a green wire. Have you had difficulty printing with ABS filament? I cannot get that stuff to stick to the Ender 3 stock glass bed, even when using glue sticks. I have never printed with ABS. I've always only printed with PLA. So I really can't answer that question. So that's just a big fat green wire, right? Yep, that's all it is, big fat green wire. So we need a green bus wire that goes over here. And wouldn't you know it, I got a bunch of that. So we're just going to cut off a big chunk of it. Like that. And that gets connected to this, and then we need to get it connected into a header that we put onto the Arduino. Like this. Okay. Oop. So solder this together. And then this gets pre-tinned wherever I trimmed it down here. Pre-tinned leads. Only 7 people watching. What a boring live stream. Let's watch Joe solder. Okay. Those two go together after we put our little piece of heat shrink on there. Get those fixed together. There we go. There's our data line. Heat shrink. Go. So that's put together there. Okay, I have to sleep now. Okay, bye. Bye, Francois. Francois, thank you for stopping by. Cool. So that's all feed-a-doodled. So now we need to make a bus connector for this. Now I need to remind myself how that works exactly. Goes into pin 9. Basically, I just shove it into pin 9. That's all I really do. This is supposed to go right in there, like that. That's it. That's really all there is to it. Now this here is pretty stiff wire, so it can act as a power lead. It just goes boop. Do you know there's translucent heat shrink that would cover less of the emitting portion? Yeah, but I'm not putting heat shrink over that at all. So yeah, but yeah, I do know. I am aware of that. So basically, that just goes into pin 9 right there, like that. So we can label that as pin 9. And look, I've got a label maker. We do 9, print. Ugh. Not quite sure what happened to my label maker label there, but it got all messed up, but there we go. Let's try that again. Making sure my label maker is actually like properly put together. Pin, oops, pin 9. Like that. So that gets labeled so we know where it goes. You can do it. You can be not stupid, please. Pin 9, great, awesome. Now, I need to make a little wiring header. So we have a wiring header that goes from some of these lower pins down here that will route from here all the way over to the gain socket. And that wiring header needs to be about 8, that's 16. That's 8 times 3 is 24. So we can make it like 32. And the colors, I have a specific color pattern I use here. Green, orange, yellow, green, blue, right? Is that what we're using? Orange, yellow, green, blue? Yep. So we're going to pull a whole bunch of wire off of my wire spool. Orange. And we're going to measure it. for me. Orange, yellow, green. Now these are just signal wires. They don't carry really any current, so they don't have to be thick wires. Blue. Where is the end of this wire? There it is. There's our little data bus, that we have made. I don't need any other wires, do I? Don't believe so. No. Nope. Cut these off here. There we go. There's our little data bus that we're making here. My label maker is a Sharpie. Yes. My handwriting is too atrocious to make small labels with a Sharpie. I can't do it. No power, just electrons. Got it. Yes. So we're going to make ourselves a little data cable here with this. We're going to twist this. Just quick little spin like that. Just make a little braided kind of cable. Twist already. Twist. Don't be stupid and twist. Be easy to twist, please. There we go. Cool. There we go. There's that. So now I need to figure out they all in a row. That's 2, 3, 4, and 5. So we make a little header doodle. So we get to make a DuPont header for that. I'm going to need that, and I'm going to need my chunk tool. Come here, chunk tool. Oop. I'm going to make a 4-pin DuPont header. Now, in theory, I could make it a much wider header that goes from like 4 all the way up to 9. But the problem is the Arduinos have this little weird split that's not an exact number of pins apart, so you can't like make headers that cross across that. So, cables in my fan that scared the crap out of me. So we need to make a little DuPont header. So we're going to need a 4-pin header like that, and then we need 4 individual pins like this. And then we crimp-a-doodle it. Crimp-a-doodle. Now, crimping these is an absolute pain in the hind end. I hate it. I hate it with a passion I reserve for, I don't know, Nazis. But we're going to do it anyway. Because we need to. All right. So we strip these little wires. Twist those a little tighter so they don't go anywhere, and then we strip these wires back. Do you have a small drill? Yes. How to annoy people wanting to make a shield with a grid PCB? Yes. Yep. You know it. I thought you were going to sleep. So we strip a tiny bit off the end of these, not too much. Yep. Okay, and then we crimp them. We crimp them down. So that is this way. Trying to remember which setting I use. I believe it's this one. These are a little too splayed to go in the small end of my crimpadoodle. And now just come out of the crimpadoodle. I hate these things. I hate them so much. No idea. They just don't want to ever go correctly. Okay, that goes in there like that to the end of that thing. Theory that's connected, we'll find out in a moment. Next. See, it came right off. I hate that. Jiminy. Ron's here. Hi, Ron. Boop. See if we can get this back in here without wasting one of these ends. They just don't, it's not really made for this thin wire. If I can get it close and just solder the sucker, I might do that. Stand by. DuPont connectors are pure evil. Yeah, that goes in there right like that. So as long as I can get that far in, we should be all right. Should be all right. Like that. Something to hold it down so I can hit it. Ah! I hate these things. Hate them. I hate them. I hate them so much. So much. Like trouble. They're just nothing but trouble. A little blob of solder solved the problem. Just a little blob. Don't move. Hatred. Pure hatred. All right, just flip it over the end and solder it right in there and be done with it. Welcome to Blur Cam. With your host, Joe. Yay! It's even, look, I even melted it into my mat. Great. That is true. Scarlet, the four-eyed Cuda, was absolutely correct. My audio was an absolute disaster for like the first 10 minutes. We'll do it on this. That'll give me a little heat protection. There you go. Don't worry, we will check all these when we're done to make sure they actually have continuity. Let's see if I can actually make one work correctly this time. Bench cam. Don't go to Hawaii. The volcano is active. Yes. So let's strip that back a little bit more. Maybe I can get a better connection that way. Go in. Do thing. Let's check that. There we go. Now that is metal on metal. That we can work with that. You don't have to worry about weird situations there. Go to boop. Metal on metal. So I just need a little bloob of solder, bloob of solder in there to solve that issue. If I can get it in there. There we go. Last wire. Green. Does it fit in the housing with the solder blob? We're about to find out. We are about to find out, aren't we? We sure are. I hate DuPont connectors. I can never make them work right. Can never make them work right. Like that. This goes in here like that. You're supposed to stop at that little ledge at the top there, buddy. Like that. It didn't even go in. Ah! Ah! Hatred. Pure, unadulterated hatred for these things. I hate them. Just live right there. strip the other ends of the wire and make sure that they actually make a connection, I guess. We'll do that next. Hola, MechFX! Am I using the right crimping tool, Joe? Yes. Crimping tool specifically designed for those. Oh, I'm not using the right wire is the problem. Kaiweet's KM601 multimeter, not sponsored, but you can go to Bruce or Dave's channel. And they will have links on where you can get one of these wonderful things. Green, green. So green has no connection, so we need to double check that. Even though it's directly soldered in place. I'm not sure how that's possible. Okay. Yep, it's there. I just wasn't doing it well enough. Okay, let's check yellow. Yellow's good. Orange. Orange is good. And blue. Yep, they all have continuity. Good. So we can proceed. Fluke better than all? You know. If you wish. So the color code order for these is orange, yellow, green, blue, as it should be, probably. Orange, yellow, green, blue. Yep. Orange, yellow, green, blue. So, orange. I'm putting it in the correct direction, yes. Orange. Yellow. Yellow. Do it, yellow. Do it. Yellow doesn't fit, of course. Is the solder too bulbous? Not really. That's not really the problem. No, just the whole connector's too big. It wasn't crimped down enough. You can't really see what I'm doing here. Yellow is, well, yellow. Yes. Go. Green. Will green behave? Green. Blue. Yay. Cool. So that's put together. That was an ordeal. That was an ordeal. So that bus line is made. So now I need to make the other end of this that goes into the, what do you want to call it? The game port socket. So let me take a look and see how that works. You can't see me. Basically, it goes space, blue, green, or blue, green, yellow, orange. Yep. Cool. So I need a 16-pin socket, I believe is what we need. 16-pin socket. What we need. Is it 16 or 18 pins? I'm not sure exactly. You can't see me. And face cam is broken. Face cam works again. I'm back. Socket. Correct number of pins. It is. Of course, now I lost it down in there because I'm a doofus. Come here, you. Come back here, fiend. Okay, 16 pins. So it's basically 3, but yep. How do I want to make this? I want to make this a little bit better than our standard socket. So I'm going to do a little experimentation. I don't think this is going to work though. It's like, could I put those through there like that? That's an 18-pin socket. Is it 18 pins? Is it really 18 pins? There's 16. 1, 2, 3, 4, 5, 6. It's 8. It's 16, not 18. Yeah. Yeah. I grabbed the wrong socket. That's an 18-pin socket. I need 16-pin sockets. Now are these down here. Wondering if we could somehow make a socket that works a little bit better. Like, can I make a socket out of Arduino head? You can't see what I'm doing. If I can make a socket out of Arduino pins here, through an actual socket or something. Wouldn't that be way too long and it wouldn't work right? Maybe? I don't know. Because these pins are definitely stronger than the socket pins, and I need to kind of like get these down, like stuck into those slots, if that makes sense. But I also want to make it in a way that's pass-through, so that basically it's going to be jammed between two sockets. So you just plug the whole socket into the machine, if that makes sense. I could just literally jam it between two sockets and call it done, you know. But I want to do it right. I'm almost wondering if I can like pull these socket pins out, solder to the backside of them, put them back in, then jam that on top of it, so that these the wires can't pull out. Oh, you were making a header, yes. I wonder if I can do that. We can try it. What's worse will happen? It won't work. Push these up out of here. 1, 2, 3. They all on the back end or what? It's 3, and then 4. Yeah, and then 1. Yep. So these little pins can come out of here. And then we can do some precision soldering or something. I don't know. Scope cam. You don't want to wreck the socket in the apple. Exactly. Like normally you would just do, you would like solder into the top of some machine pins or something like that, but machine pins will wreck the apple socket. They'll just destroy it. And I don't want to do that. Also, again, this is a kit being sent to somebody too, so it's not like, here, desolder stuff inside your apple to make this work properly. Like that, we're not going to be doing that. That's not a thing that will happen. So that is definitely out of focus for you guys. That's closer. There we go. Just kind of touch these with a little bit of solder. Just touch them. Just so they'll stick when I do the thing. Okay. And now we need to just kiss the outside of these. Just tiniest little dip. Kind of right there. Oh, I can't see. Tiniest little kiss. My cat likes the wires. So cool to watch it get built. Well, hopefully I'll get it done tonight, Eric. We'll see. Again, remember this is going to be a kit, so the wires are going to be a little bit longer than what I would normally make, only because I don't know exactly how you want to route your wires and do all that. But they can just kind of be coiled up and tucked under a corner. No big deal. It's a little too much. Skim off that. Okay. Now we can turn these this way, so I can use my right hand to hold the things while we touch them on there. That really doesn't want to be flat, does it? There we go. I'll have to be more up to the top here. More up here. Well, we'll roll with it. We'll see what happens. Blue wire's next, because it's the closest one. And finally, the green wire. All right, let's see if those will fit into the thing. It's also an imprint of Joe's thumb, yes. Let's clean the extra goop off those. Because that stuff does not conduct electricity. It's basically chewing gum. I don't want to come out of there. I'll kind of pick it out. All right, cool. So again, I'm double checking over here. I'm gonna double check. Boop. I'm gonna double check my pinout here, and it is 3 dots: blue, green, yellow, orange. So we go. Boop, boop. One wire at a time, please. Blue. Blue. Green. Green. Yellow. Yellow. Hello, yellow. orange. And boop. There we go. Cool. Look at that under the scope-a-doodle. See? All wired in place. Nice and jammed in there and soldered in place. And then I can put this other socket over top of it. And it will really jam those wires in there. So those are not coming out. Wires proceed to come out. Okay, there we go. Wires. Yep. Cool. That's our little socket adapter. So let's clean up our mess a little bit. Just a little bit so we have some working room here. Okay. So this connector goes 1, 2, 3, 4, like that. Is it 1, 2, 3, 4 or 2, 3, 4, 5? It is 2, 3, 4, 5. Yep. Starting with orange. Yep. Like that. That goes into the Apple II. This comes from the LED kit and goes into 9. Like that. This gets powered off of the Apple II. This also gets powered off of the Apple II. And that's it. And basically, well, I have to upload the code to this. So we will do that next. What? Hey, Bob, how you doing, sir? Get this little USB cable and get this thing hooked up and programmed. Like this. Face cam. Super face cam. Lemon Herb's here. Herb knows about this. He has also built one of these kits for himself. Trina's here. Hi, Trina. It looks like the basic code you wrote for the NeoPixel kit doesn't like the Apple Squeezer accelerator. It just basically ignores any commands I enter. That's very interesting. It works with the fast chip accelerator, which I have in this, and it works just fine. So that's Apple Squeezer's problem. Ooh, is that blue tack? Yes, it is. Figure out that I can't solder fine pitch SMD connections. Yes, those suck. Yep. I'm just checking back on chat. Yes. Yes. What about the purple wire? No purple wire. Toothbrush? What toothbrush? Cool. I wish I had some talent for video production. I don't have any talent for video production. When was the last time I produced an actual video, Herb? When was the last time? I'm just live streaming. I'm just sitting here goofing off and telling you what I'm doing as I'm doing it. That's not talent. That's me talking to myself, but with people watching. Yes. Yes, that's it. All right, so let's get this plugged into my computer. It's plugged in. I need to go figure out what serial port it's using. Device manager. Serial port is COM3. So then we need to go to the Arduino application suite, and we can go to that, and you can see what I'm doing. So we go to tools, and it's the Uno. The port is COM3, and in theory, I can hit sketch, verify, compile, and compile it. It worked, no problems, and then we upload it. COM3 access is denied. Why? Do I have to run the frickin' Arduino application as a administrator or some such stupidity? Probably. Let's try that again. Upload. Access is denied. Tools. Why is access denied? Programmer. It's like, no. I haven't used this in so long. GVRD. Arduino Uno. Arduino as ISP? I have no idea. COM3. Why is access denied? I don't know why. It shouldn't be. Okay, I had another program running. Nope, I figured it out. I had another programming running in the background that had COM3 tied up or something. Cool. In theory, I should be able to plug all this stuff in and it'll work. Maybe. So let's start plugging stuff in and see what happens. So that is 3, 4, 5, 6. 0, 1, no, 2, 3, 4, 5 right here. Goes here, bench cam. So that's 2, 3, 4, 5. Right? Which doesn't matter actually for the default, because when it turns on the first time, it will send the program to it'll send the default program to the NeoPixel set. So I shouldn't need to plug in the command cable yet, because that would require me connecting it to an Apple II, which we're not at that point yet. So we need to do this. Command wire, so that goes into 9. This goes into 5 volts. That right there, as well as this. Both of those wires go into 5 volts. If I can get it to work it. There we go. And these go into ground. Ground and ground. You can do it. You can do it. Go in there. Okay, well, we're just going to skip over and use this other ground wire. In theory, this will work. So if I turn this on, this should light up. Nothing occurred because I didn't plug this part in. That's important. Well, we got something. So we got one blink light. It's kind of sort of doing the thing. You can kind of sort of see it working. So something's not quite right, but we're getting there. This ground wire came out. This ground wire came out. That's our problem. It doesn't have a proper ground. This wire right here goes in here. There you go. The default works. That's it. So that's all done. So the hard part is done. Now we need to plug it into an Apple II and actually like see if it runs the program. That's a little bit more difficult because I have to like ground plane bond this and stuff like that. So I'm probably not going to do that on live stream, but it does function. Now let's add flash and Taschen support. What is that? It sounds cool. You need to tell me now. I'm requiring you to tell me what that is. So we can play videos from VLC on that. Yes. Yes. Bing, there you go. See? No, videos for VLC. That's what that's for. Instead. That's that. Cool. All right. Well, that was fun. So at this point now, I have to do some crazy running around knees-bent advancing behavior to get this thing connected to a computer so I can test that the actual command protocol works, which is not straightforward. I kind of have to like tear down an Apple II and do it. Yeah, and I don't know if I want to do that part on live stream tonight, unless you guys really, really want me to do that. So you let me know, and we'll take a short break while we are talking about that. It's some RGB LED based thingy using beer crates with one LED per bottle, which makes screens like 25 by 20. Yeah. You had a support for the protocol in VLC when you visited NoiseBridge. Dude, you're awesome. You are the bomb. NeoPixels are awesome. So yeah, so that's the question is, do we want to actually try to tear down an Apple II tonight? Or at least enough so that I can connect it to make sure the protocol works. You let me know. Will Jacobs is here. Hi, Will. How you doing? Cool. Trina's like, I really, really want you to. Well, this Apple II up here is pretty much already set and ready to go. I might use that one. I'm just trying to think of which Apple II I would use to do that and how easy it would be to get one apart. I'm thinking. Stand by. I'm thinking. Which one should we use? I'm thinking if I use this Apple II down, and not this one down here, all I have to do is take the cover off of the top of it. That'll give me easy access to it. And that's it. About to dump this 3 Plus for the night. Yeah, Will is working on an Apple III that he acquired recently. And he's been kind of pinging me an email a little bit, trying to help him out with that. Which, you know, as with every Apple III, it's pray, check all your chips, pray some more, drop the thing 3 inches onto the counter, pray some more. So yeah. So what I'm going to do right now is we're going to do a little cleanup. I just need to clean my bench so I have the space to get the Apple II up here to do that. And you can watch me clean. And then I'm going to take a short intermission to take a restroom break and grab another yummy, delicious soda here in a minute. And then when we come back, we will watch pieces of paper drop off of the ceiling here. No, we will get the Apple II up here and we will connect it and you can see us program the thing. So that will be cool. So that goes up here and we're done with soldering. So that noisemaker goes up there and this goes over here. And parts and pieces and these go up here. That. Doobie-doobie-doo. If Herb is still there, as I'm cleaning up here, I'm thinking about the problem you're having with the Apple Squeezer. My guess is that the Apple Squeezer isn't as smart as some of the other accelerators, and it's accelerating communications to the. It's accelerating certain I/O communications. Most accelerators will not accelerate I/O comms to the game port. They'll slow those comms down. Even though the Arduino's fast enough to deal with the comms in theory, my coding is absolutely atrociously awful, and it's probably not fast enough to deal with an Apple II that is communicating with it at 16 megahertz when its own clock is only 32. So that's probably the issue. So yeah, I don't really have a suggestion there. Stand by. Just recycling a pop can there. So I'm really not sure what to tell you on that one. Herb, not sure if I can link my video of mine working that you have. Let's see. If I click this and I make you a moderator, Herb, you are now a moderator. You may have to refresh the stream, but you can now post links. So this is all set up. So this I need to get these little wires out of the way and get this out of the way. Okay, power supply, we'll probably use this, hook it across, do the thing, got it. Got it! Got it! Okay, so I'm going to take a couple minute break. So you guys can also take a couple minute break while I take a quick sabbatical and grab some tasty, tasty beverage, and I will be back. I don't know, in about 2 minutes. Stand by. I have returned. Yes. See, the cool thing about Herb's is that his is a Stealth GS. The mic was hot during the whole intermission, Joe. Was it? I thought that muted. Can you hear me? Can you hear me? Can you hear me? Hopefully I didn't say anything embarrassing while I was supposedly muted. It's because I was futzing with the settings to get this to work, and when I do when I go off live, it mutes my mic, but it doesn't mute like all of my mics. It only mutes the mic that I had specifically set up for StreamYard, so it didn't actually mute my mic. But whatever. That's not Pepsi. No, this is yummy Coke Zero. Can I be a mod? It depends, Trina. What do you want to do? Do you want to like drop some links or something, or what you want to do? Don't spill that Coke in my G5. Welcome back, Garth. Yes. So yeah, copy, paste. I will ban those bots. What bots? There aren't any bots. Is Coke Zero G5 safe? So we need to get this Apple II here over on the bench. I'm going to take the lid off of it so we can get to the guts without completely taking it apart, so we can get these bits and pieces put together and do the thing. So let's get on that right now. We'll stick on side cam or face cam for now so you can see what I'm doing. So let's very carefully slide all this stuff to the side. Very, very carefully. We don't want any shorted wires. That would be bad. Bad mojo. That would be bad days. Come here, you. You live right there for now. This is my testing Apple IIe that I use for all different types of testing processes. This is also my original Apple IIe, the first one I ever got. I use it for everything because it is an absolute tank. It is a boss. It just frigging works. No matter what I do, it's like, yes, sir, let's go. We're doing it. We're doing it live. So it is what it is. That goes out of the way. I will need that chip to put back in there for the keyboard, but that's fine. Let's take the lid off of it. Now I'm going to tick off everybody in the chat because, yes, I'm going to use a drill. The reason I'm using a drill is because I know how to do it correctly. Take out all of these outside screws. For those of you who have never taken apart an Apple IIe, these are the screws that come out first. Okay. Be a little bin to put these in. Little bin to put these in. There we go. And then this gets flipped back over. And the lid comes right off. Look at that. Isn't that magical? Isn't that special? So now we can put this power supply on top of here since it's already wired up for everything, and then do the thing. So yeah, I kind of have to wire this connector back in over here that you can't see, but we will deal with that. So first things first, let's kind of rearrange some stuff a little bit here to do the thing. I need to put my keyboard encoder in it. The replacement universal keyboard encoder for the Apple II and Apple III computers right there from jcm-1.com. We're going to be using this power supply, which means we need to do some wire jamadoodles to make that work. Because specifically of the way I had things wired in here. So let's do some quick wire surgery. That, okay, because these wires need to go back in here in order for this to work correctly. And I may have to do some magical wire doodles here to get these wired properly, but we'll see. Those are 5 volts and ground. There we go. So in theory, this machine should now be able to run from this power supply. This has been liberated from this. Just go up here for a moment. So in theory, I'm also going to disconnect that for now. So this goes in here like that. I think that can live on the outside like that. This goes in here like this. And we flip the switch. Beep! Turns on. No problem. Bob is your uncle. So let's actually get some video plugged in here so I can make sure that the machine is doing what it needs to do. I need to figure out how to do that. Stand by. Let's see. I'll even see if I can put the video up on the screen for y'all. How's my audio sync? Is my audio sync still broken? Boop. I don't think that picks that up. Nope, but that's okay. We will work around the problem. Power. I need to go to input. Put that on AV1. There we go. Cool. There we are. Great. Sorry. Hard to see that. You can't really see that. There's the Apple II screen. Can I put that on like bench cam and like swing the bench cam around so you guys can see that monitor or something? Maybe, I don't know. Because my side cam isn't broken right now. It's not functioning. Like it doesn't do the thing. I don't know why. Why not working? Not sure what's going on. Oh, man. Like my whole setup, which has been working perfectly fine for months, just before this stream, just decided to fall over and stop working. You figure that one out for me. I would love for you to figure that one out. Probably, I'll bet you it changed Wi-Fi networks or something. Bet you if I do that, it'll start working. There we go. That's what it was. Side cam's working again. Boop. And boop. Yay! Cool. So you can see that. Awesome. So now that that's working and we know that we can get that working. I don't know why the 9 key is stuck down on this. My keyboard encoder is busted. I don't know. find out here. Put my real keyboard encoder in. Okay, weird. All right, whatever. Just rotate the screen 180 degrees. You blame Retro Techie, Garth. Me too. Although I have to be kind of nice to him. He put me onto this really cool S100 system that's only about an hour and a half away from me. He's like, Joe, go bid on it. It's like $13. And I'm like, done. So yeah, Retro Techie really is a nice guy. We give him a lot of crap, but he is super awesome. Good thing I can get a replacement keyboard encoder for JCM-1.com. Yes. Here's this keyboard encoder, but you can see this one's been hackadoodled. This was a what you might call a factory reject. So whatever. Where are we? So we are. We need to get the NeoPixels connected to the computer. So that's what we need to do. So I'm going to show you me doing that thing. So this is a little tricky. A little bit tricky, just a little bit. Stand by, I need to move. I have a box here that's in my way. As our wonderful friend Steve would say, hold please. Or his other favorite phrase, you silly goose. So that's cool. So I somehow have to get this plugged into this while also plugged into that. So that's going to be an interesting situation. I'm not quite sure how I'm going to accomplish that, but I'll figure it out. I always do somehow. Like I have to get all these wires jammed down in there. I might be able to make it happen. So power's off. So this needs to go down in that ground wire. It's a little fat. Maybe we can lob this little nub off the end of it and get that to fit better. Really doesn't want to stick in there because the wires are too fat. The numbers you are using to dial, or the fingers you are using to dial, are too fat. I'm just trying to thin this down a little bit. Maybe it's going to work. Maybe it's not. It doesn't want to work. It doesn't want to work. Normally, this isn't a problem. This is a customized version of this power supply. Let me see if I've got one that works in the reverse. That might help me out a little better. No, I don't, unfortunately. I do not. So I might resort to some craftiness. problem is I don't know what, yeah, I do. It says right here. So basically, this is ground. That's ground. This is also ground. And then 5 volts is red. Yep, that's easy enough. Need some stuff up there. Cool. That does that. That's connected that way. This goes in this socket right here, like this. This goes in here like this on 2, 3, 4, 5, like that. Like that. So in theory, if I turn this on, it should work. Well, that's grumpy. That's not doing anything. Might not be getting ground or something. Yep, this connection isn't good. That's our problem. This connection is not good. And that's got a bad ground is the problem. Yep. We just got bad connections. Just got bad connections. That's all the problem is. There we go. Cool. Yay! In theory, if I plug the correct software into this thing, so we're going to go to that. Let's see. Do I have software on here? Don't believe I do. So we'll have to get the software on here. Stand by. I have a disk image for this already. Need to put on here. Boop. This message is held for review. I have no idea what that is, but I'm assuming it is an insult in French. So we need to do this. We need to go to here. Go to here. Do copy. Do paste. Eject. That works. Huh! My face cam isn't looking at my face. Like, what is that? What is that? What even is anything right now? Just like, can you do the function? So let's do SciCam. Cool. That's not the right power supply. There we go. Smart port assignments. Go over here and we do delete. We hit escape and we boot slot 7. Cool. We're just going to load that. Cool. So it is working correctly. Sweet. So if I were to go, so right now, if I tap 1, it just flips to specific modes. It's switching between the different pre-programmed modes that are in here. So if I go to here and I press that, you can see it changes the mode. Hit it again, it goes to fade mode. Hit it again and it's twinkle. Hit it again and it's just solid colors. And again, it's chase. Woot, woot, it works. Awesome sauce. So there's we've got other commands here too. So I could do fill strip. So I could hit 6, and I want to fill it with the color no red, all green, and half blue. And it wants the start. The start will do pixel 0, and the end pixel 60. Parsing bits, sending, boop. So now if you look at there, it's a nice cyan color. Cool, huh? Isn't that nifty? Isn't that the coolest thing? So let's do that again. Let's say I want to fill the strip with, from red. Red we want 255, green none, and blue a little bit, 128. And the start 0, and the finish will do 29. So only half the strip. Parsing bits, sending, boop. So now if we look, half of the strip, it's kind of hard to see here, but half the strip is purple, and the other half the strip is pretty blue. Isn't that freaking nifty? Isn't that the coolest thing since sliced bread? I love it. It's so cute. And then I can give it individual commands, like I can do the chase command. If I just hit 8, it'll just put whatever is in there in a chase mode. So you could pre-program it with your own color scheme, then just send it the chase command, and it'll just chase it automatically. I could also do fade. So if I do 9, it'll just fade in and out whatever's already on the strip. So you can color this with any color scheme you want, then give it and either of the two animations, chase, fade, or solid. It's just great. Now for disco. You want disco? Okay, we'll hit 5. Apple color twinkle. There you go. Here, we'll turn off all the lights so it's like super twinkly. Twinkle lights, twinkle lights. Doots, 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 doots. Yeah. That is the coolest thing ever. I love it. So the only problem with the can you play Doom on the strip? Yeah, that'd be great. So the only thing that this system needs added to it is a save feature to where you can save the current state in the EEPROM of the chip. So when it reloads, it just reloads the previous state. This does not do that. It should be a relatively trivial add to the code for me. But in Joe's relatively trivial standards, that's like probably 4 hours of work. That's like a whole night of work for me to figure out how to do that. Because I'm just not that good of a programmer. Like I know how I have the concept in my head of how to do it or what needs to happen, but I have no idea the programming, the specifications or anything of this specific Arduino and what code to put in the Arduino program to actually make it work. I have no idea. No clue at all. No clue. Don't know. So that is that. But yeah, it's working. It's working. So Mr. Eric that I built this for, your NeoPixel strip is built. All that needs to happen is plug it into your Apple II. I will send it along, of course, with specific instructions on how to actually make it do the thing. And that's about it. that was my task for tonight, was to make pretty lights blink on the Apple II, and we made it happen. Facecam is off sync. Yeah, all of my audio and video is broken tonight. I don't know why. I have been running the setup for months without a problem, and tonight I'm like, I'm going to stream, and nothing freaking works. I don't know. I don't know why. Yeah. Can use a bunch of strips and display a block of RAM as a kind of freakish memory monitor. That would be cool. You could do that. Using this base, yes, you would need to, using hex values, setting hex colors, yes. That would require a little extra programming on the Apple II side, probably in assembly language, where you would type a command in the Apple II, and what it would do is it would dump just the hex bytes directly to the NeoPixel. It would be a special mode that the Arduino would know about, and it would just take that data in and then show it on the array. I can actually kind of show you the code, a little bit of how it works. If I can do that, let's see here. Do I even have it open? Is it open? No, it's not open. Hillbilly Shack, I think I got that ABS printing problem solved. Magnetic bed conversion. Yes, yes. I'm not a fan of glass beds. Or sidetrack 3D printing. I love the magnetic plastic release beds because they have a texture that it makes the lines in your print disappear, and it makes a nice soft old school plastic product texture on the surface of your prints, which is neat. But it also, your prints stick to that really well because there's a little bit of a texture. But because they're plastic, you can release them from the bed really easy by just taking the whole magnetic plate off and just going like that, and they just pop off. It's amazing. I love those. Those are my favorite. I don't like the metal beds. I don't like the glass beds or the corundum beds. Or the sapphire beds or any of that stuff. Yeah, Bob is using PEI on spring steel. PEI on spring steel is my second favorite. I'm going to have to try it. The printer that I have set up with my PEI on spring steel was the one I did my relatively recent live stream. It was like a couple months ago. Where I built that Ender 3 S1 Pro. That printer, I don't know what's wrong with this specific printer, but it's inconsistent for large scale mass printing. I tend to, not that I'm like doing huge high-end pro stuff like a lot of these pro 3D printing shops are, but I do kick out enough volume that I need the printer to be consistent between prints, so that I'm not spending 15 minutes between each print playing around with bed leveling and stuff. This thing it's not consistent between prints. Once you get it set, you can get one or maybe two prints out of it from that bed level. And then it doesn't matter about auto bed leveling or any of the G codes or any of the stuff you set, it won't keep the level. It won't keep it. It won't reset it. You've got to manually level it every time anyway. And there's no updated firmware to fix it for this specific model. So it's basically like having an auto bed leveling printer that doesn't auto bed level. So you manually level it. So it's fine. I mean, like, it prints great when it's level. I'm kind of off on a tangent, but I don't have my Ender 3 Pro, which is my rock solid standard. I leveled that once, like 8 months ago. I haven't touched it since, and it just kicks prints. It just kicks them and kicks them and kicks them. I don't have the PEI spring steel bed, proper matching magnet bed setup for that one. So anyway, back to what we were talking about. I was going to show y'all the code, if I can. Can I zoom in? I can. Yeah, we can show you the code for this. So here's the code. Code to drive a NeoPixel strip from Apple II by just shares. As far as Arduino, your mileage may vary. Now, Adafruit created a specific how can you put it? A library for talking to NeoPixels, and you can look that up on their website. That's what I pulled in. Their NeoPixel, technically speaking, is their brand name for WS 8112. Addressable LEDs, and they have kind of the definitive driver for that. But so that's what that. I define the pin that we actually send the data out and the number of LEDs. This is just creating some different stuff and some defines to say how things happen. Here are some color constants to make my life a little easier. And then here is the default array that when turned on is what gets sent out to it. It's the apple colors, as you can see. More pin definitions and all of that stuff. These are modes and things. These are just definitions. So we set up the thing. We attach an interrupt driver on this so that when the Apple II pings one of the pins on the Arduino wakes up and knows, hey, I need to be listening to stuff being sent to me. And then we've got a data pin, a clock pin, a command pin, which are special pins for things. And this just shows us, blanks the strip and does the thing. And then basically, I want to, this is just the primary logic loops. I wanted to show the actual inject. Yes, so injects an existing data array into the strip. Basically, what we do is we create an array of 60 values, each one which is the hex value of the color we want to send to each pixel, and those are what get passed out. But we need to stand by. I'm refamiliarizing myself with the code. That's the internet handler. Yeah, there's a really nifty loop here that deals with talking to the Apple II, which is what I actually wanted to do. Yeah. Okay. So this is what interprets each of the commands that you can send to it. Commands are very simple. Like single byte instructions that the Apple II will send to the Arduino, and the Arduino will then just do a pre-programmed thing based on that command. So you send it a command, and then the Arduino knows, oh, I just need to start fading whatever's already in the strip, or I need to receive, like command fill, I need to receive via these 5 arguments a specific amount of data from the Apple II, and just stuff like that. Here's the real meat and potatoes from this. Basically, if the command pin is low, meaning, hey, I'm sending you a command, and while the clock pin is low, it sits in this tight loop and waits for effectively the clock to be clocked. When it clocks, when the clock pin changes state, it knows to take whatever's on the data pin and add it to the array that we're going to be doing that, and it just sits there in a loop. So it's basically kind of like a bit banged 1-bit serial, clocked serial data thing. And so basically every time the Apple II changes the state of the clock pin, then the Arduino knows that it needs to read that data bit by bit into the array. As you can see here, it's adding the bits. And then once it's done, basically, when the Apple II is done, it will then sending its command in. It then sets the command pin back to high, which means that the Arduino breaks out of this loop, and it knows, okay, so the Apple II is done sending me the data. It's done, right? And so then we send the data into the strip and play the thing and do all the thing. Extra credit project, use the built-in SPI hardware to read the data for free. Yes, I could do that. that would be more intelligent. I built this a long time ago before I knew most of anything about anything I was doing. I think I designed and built this right around the same time I was working with JCM 1. So I was very newbie and didn't know about things, so I programmed this manually. Could it be reprogrammed? Absolutely. I'm not 100% sure if the Apple II could like fully implement SPI over that port. I don't know. I'd have to figure it out. But yeah, so it is a thing. The only thing I would do here is in order to like add the ability to save the data between boots is right here. On every call to inject, we would go down here at the end of inject before it ends. We would take whatever the array is that we injected, basically, like somewhere right in here, right in there somewhere. We would add that. We would somehow save that array of data to the built-in non-volatile memory on the Arduino. And then all the way at the top here, when we're initializing it, this color array, instead of initializing it as this variable to a known state, we would actually pull it in from the non-volatile RAM. That's really all that would be to doing that. So that, say, you know, right now it's in this mode. It's in this blinky twinkly color mode, right? We could save that information, and not just the color array, but also like the current, you know, mode byte, the state byte or whatever. We could save that state byte as well. And so every time it loads, it would know what mode it was in. It would just execute that mode on startup. General flags, void setup. Yeah, like on strip begin here, start the strip. You can't really see what I'm doing. You know, here are these modes. Right here, we can choose one of the. We can save this mode as in the non-volatile RAM as well, and state equals 0. We pull that in from that, so we know what it is. And then right here on strip begin, strip show, or whatever part of the setup routine, where we're actually setting it up to say, go, start drawing the thing. Instead of strip show blanket to 0 or whatever, we would be setting it to its previous state. So easy peasy, straightforward. It would take me probably all night to set it up and do it, but it is a thing. So that's it. That's really all there is to it. We got the whole thing figured out. Yeah. I don't know. I'm just sitting here mumbling at this point. Not a good explainer. I don't know how to put it. When I'm explaining things, I like a script. So I can just read the script, because what I can do is I can type it out ahead of time and get it all figured out, and then just read it off without making lots of pauses and stops and trying to go back and correct myself because I misremembered something and blah, 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 blah. Anyway, I do like Nick Lopez's extra credit project of using the built-in SPI hardware instead. That would be really nifty. I just have to figure out which pins connect to what on the Arduino to do that, and then do that. I'm not 100% sure that's possible. I don't know. I have to look, because the built-in SPI protocol may be reserved, or how can I say, latched up, associated. I don't know. I'm not familiar enough with Arduino to know exactly, but it may be tied somehow to the code that sends the data to the pixel strip itself, which, if that's the case, I might not be able to redeclare it or redefine it and reuse it in a different different routine on a different pin. I don't know. I'm not sure. So yeah. I can only think of two reasons why I didn't use it originally. Either one, I didn't know it was a thing and didn't think about it. And it was just like, reinvent the wheel because I know how to reinvent the wheel. Or I couldn't because I ran into a problem. So NeoPixel shouldn't be using the SPI hardware. Star Pixels do. Hey, look at you knowing things. I probably just reinvented the wheel because I didn't even think about SPI. So yeah. And see, that's the thing. I should know about SPI because the NeoPixel came a year after JCM1. And I know I'm aware of SPI because I implemented a pseudo SPI mode using one of the 6522s in JCM1 in order to control the digital potentiometers that I used for left-right panning of audio. So I should have known about it. It probably just, you know me, my brain is I don't know. It's like a sponge. It absorbs things, but the holes are too big and the stuff falls out too. So I don't know. Anyway, we are going to call it for a night. We got the thing done and ready for the client. That is good. I just need to clean it up and document it a little bit and get it packaged up in a nice neat package to send out to our client. And that is all. I would like to thank all of the super awesome people hanging out with me tonight. Very much appreciate it. Thomas and Herb and Francois. Jeremy was here. Bob, Nick, One Bit Fever Dreams, Frank, Trina, Garth, whole bunch of people in the background who stopped by to say hi, make the stream a really cool thing. Remember, while you are here, if you like the stream and all of the wonderful technical failures that we had tonight, hit the like button. It tells YouTube to show my video to other people that like the same stuff that you like. And so it kind of helps make our community a little bit bigger. If you're not subscribed to my channel, subscribe to my channel. Do it. And if you really, 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 really like me, you can support me financially by going to Joe's Computer Museum on Patreon right there. And as little as $1 a month, you get to hang out with me with these live streams. And my patrons get to have Discord access. And sometimes I get to have you guys as guests on my stream. I didn't want to do it tonight because I was really focused on getting this done, so I didn't do it that way tonight. But many nights I do that. You can go to jcm-1.com and get really cool trinkets like replacement keyboard encoders and T-shirts that say Thingamaboob on them. You know Thingamaboob? You remember?
Thingamaboob.
That thing? You can get T-shirts that say that. And stuff like that. So cool stuff. So I'll go ahead and end this tonight. Again, thank you all for stopping by. And remember, 8 bits are all you need.